Hello all, this is Tom from Tutor Bros. Today we are going to look at a conditional statement and its variations, namely its converse, inverse, and contrapositive, and then we will determine each statement's truth value. Now, since this is a multi-part problem and there are quite a few steps involved, we're just going to do one example together today. So we start with the conditional. Remember that a conditional is just an if-then statement, if this, then that. And the first part of the conditional would be the hypothesis. So that would be here, and we use the letter P to indicate the original hypothesis. And the second part would be the conclusion, and we use the letter Q to indicate that. All right, now we want to rewrite the conditional in its variant forms. So the first one would be the converse. The converse is when we flip the original hypothesis to the conclusion and vice versa. So in this example, let's look at the conditional first. We have if x plus 2 equals 3, then x equals 1. So if we write the converse, we have to take the conclusion and make that our hypothesis. So the conclusion is that x equals 1. Then we can rewrite the original conditional as its converse by saying if x equals 1, and then the hypothesis again becomes the conclusion. So then x plus 2 equals 3. And then if we just go back for a minute, the conditional, the symbolic form is written like this. So P arrow Q, we say that if P, then Q. Now with the converse, since we're switching the original hypothesis and conclusion, we would say Q arrow P, or if Q, then P. All right, now we'll move on to the inverse. The inverse is when we negate the original hypothesis and conclusion. So we start with the conditional again, if P, then Q. And then we say not in front of both the hypothesis and the conclusion. So we'd say, if not P, then not Q. And then in this example, it would look like this. If x plus 2 is not equal to 3, then x is not equal to 1. And then in symbolic form, we would write that like this. So the little squiggly indicates not. So if not P, then not Q. Alrighty. And last but not least, we will look at the contrapositive. So the contrapositive is when we switch the hypothesis and conclusion and negate them. So essentially what we're doing is we're doing both the converse and the inverse in one step. So in this problem, the contrapositive would read like this. If x is not equal to 1, then x plus 2 is not equal to 3. And in symbolic form, we would write that like this. If not Q, then not P. Alrighty, so now we have the conditional statement and all its variations. Now what we want to do is we want to determine the truth value of each of these statements, which simply means we're just going to determine whether or not they're true or false. So if we look at the conditional, we have if x plus 2 is equal to 3, then x equals 1. Well, we can solve that original equation, x plus 2 equals 3, and we would get 1. So we can determine that this is indeed a true statement. So I'll just write a little check mark to indicate that that's true. Now to make this easier, we can go back and remember that the conditional and the contrapositive always have the same truth value, meaning that if one of them's true, then the other one has to be true, and if one of them's false, then the other one also has to be false. So since we've already determined that the conditional is a true statement, we don't even have to read through the contrapositive to know that that also is a true statement. So we can just check that one off and say that that is true as well. Now what about the converse? If x is 1, then x plus 2 equals 3. Well, that seems to be a true statement as well, because if x is 1 and then we plug it into the equation x plus 2 equals 3, that reads as a true algebraic equation. So I think we can say that the converse is true as well. And then similarly, we can remember that the converse and the inverse also have the same truth value. So they're either both going to be true or they're both going to be false. So since the converse here is true, then the inverse must also be true. Now, since all 4 of these statements are true, we can write the original conditional as a biconditional, meaning we combine the hypothesis and conclusion with the phrase if and only if. And I'll show you how to do that down here. So, oops, give me one moment here. So the biconditional. Alrighty. We can say that the original hypothesis, x plus 2 equals 3, if and only if x equals 1. Alrighty. Now remember that a biconditional is true, or we can create a biconditional from the original conditional statement only if all 4 of these statements above are true. So again, the biconditional would be x plus 2 equals 3 if and only if x equals 1. And symbolically, we can write it like this. P, Q. So it's the double arrow pointing both ways. So P if and only if Q.